So our lesson for 10.3 part 1 is what we're going to do in the nonlinear functions unit. So if you're looking for 10.3 part 2 in the quadratics function, keep looking. This one we're going to talk about the standard form of a circle and how you can identify the center and the radius of that circle, and then you can graph. And we're going to want to go backwards too, where I give you the graph and you write it back as an equation. So, woo, what happened there? Before we get to identifying anything, you know what the standard form of a circle is. So I'm going to use colors here. My pen will work. Okay, but and it's x minus h squared plus quantity squared, y minus k quantity squared equals r squared. So the h and the k and the r are in different colors because those are the three things that you have to identify in order to graph a circle. This should look like Pythagorean theorem, and we could go through proof of why it's Pythagorean theorem, but we don't have time for that right now. So the center of your circle is located at, I have guessed it by now, HK. And then R stands for, if you think about circles, it is the length of the radius. And if you have those two clues, the location of the center and the length of the radius, then you know how to graph it. Now that we have our formula, we should be able to figure out some things. So this first one, the center, you can abbreviate it like this, is located at HK. I don't know if you noticed, but in the formula, it was grouped in parentheses with built-in negative. So we're going to have that same, like, take the opposite or incorporate the built-in negative component. So the H value is a 2, and the K value is a 1. And the length of the radius is the square root of this. The length of our radius is 5 units. We're not graphing yet. We're just coming up with the location of the center and the location of the radius. So in here, the center is at, location of center, is at negative 12, negative 8. And the length of the radius is the square root of 49, which would be 7 units. Okay, so now we're going to go a little further. We're going to identify the center and radius, and then we're going to actually graph it. So if you thought my other graphs were bad, wait till you see my circles. It'll be awful. All right, so this one's a little unusual because it doesn't quite look like the formula. And the reason for that is there is a 0 for the H and a 0 for the K. So they don't bother writing x minus 0 squared, they just say x squared. So in this case, the center is just at 0, 0. And the length of the radius is 4 units. So plotting a point at 0, 0. And then the radius is the distance from the center to the edge. So for most people when they graph a circle, they just do the like north, south, east, west directional plots here. And we are supposed to, oh man, oh boy, not good. It's not good. Hopefully your circles look like circles. Ding. All right, the center location is at, remember opposite signs, or it's a built-in negative, the HK. So we have a center at 3, negative 4. And then the radius length is the square root of this, so the radius is 2. So plotting a center at 3, negative 4. And then radius of 2. Let's go up 2, down 2, right now my face. You know, for me, that's pretty good. We'll call it a day. All right, so here, the center. This time, it's just kind of partially weird here because the H value is 0, so we're going to have kind of a weird looking partial equation there. So 0 squared, x minus 0 squared is just x squared. And then the K value, remember, built-in negative is a negative 1. And the length of the radius is 5. So your center is at 0, negative 1. And then going up 5 units, down 5 units. To the right, 5 units. To the left, 5 units. I'm pretty certain I'm not going to be able to make a circle there, so pretend and use your imagination. All right, your center location is at built-in negative, -3, 0. Oops, wrong way. -3, 0. And then, oh, this is weird. The square root of 14. I'm going to need to estimate that if I'm going to graph it. I don't know. I mean, kind of know what it is, but it is 3.7-ish. So when I go to graph this, the good news is, since I can't graph, I'm not going to be that picky about you guys either, but I need to go 3.7 units up, down, right, left. So, like here, maybe 1, 2, 3, not quite 4. 1, 2, 3, like here. 1, 2, 3-ish. And then again, connect and make your circle. I'm just going to put myself out of my own misery and stop trying to draw a circle. Okay, so here, I'm going to give you the information. I want you to go backwards and place these things into the formula. So, you can start with a skeleton of the standard form, and then we can kind of simplify from there. So the h is 0, and the k is 0, and the radius is 14. So the best way to write this, instead of saying x minus 0 squared, let's just say x squared plus 0 squared, y squared, and then 14 squared is 196. So that's the most simplified version. If you were taking an SAT test, that's probably the version they would be giving you. So here, again, filling in the skeleton of the formula, that's fine. Careful on the x, or the h and k though, because you have a -6 for the h, and then -8 for the k, and then a 6 for the radius. So simplifying this, we're going to have x plus 6 squared, and then y plus 8 squared equals 36. Simplified version. All right, so here, I'm going to give you a graph, and we're going to kind of work backwards and figure out the formula. So this is the center of the circle, and be careful because once in a while the grid marks are representing something other than 1, so be careful on the labels. So the center is located at -4, 4. So you have your h and your k, and then your radius, you just have to measure it from the center to one of the edges that are directly around. So 1, 2, 3 is the radius, right? So going back into our formula, we're going to have, you can write x minus -4, but that's just going to change and simplify to an x plus 4 squared. And then y minus the k, so y minus 4 squared, equals, you can write 3 squared, but I'm just going to go ahead and write a 9 and skip a step. All right, this time your center is located right there, which is at the ordered pair 0, -3. And then, got a radius of 3 again. Fun. So we have center at 0, -3. So instead of writing x minus 0 squared, let's just say x squared. And then instead of y minus -3, that'll become a y plus 3 squared equals 3 squared, which is 9. All right. So we are going to extend this lesson in the quadratics unit when we learn about something called completing the square. If you're looking for that lesson, that is 10.3 part 2. It'll be in the Algebra 2 playlist.